So for almost 90 years, we've just, you know, casually accepted this completely ridiculous premise, like an alien baby crashes on Earth and just becomes a literal god because, well, our sun happens to be yellow.
Right, we just treat it like magic.
Exactly. But if you actually look at the real-world astrophysics of star colors, the craziest part of Superman's mythology isn't the magic at all. It's how closely that comic book lore actually mirrors the violent atomic reality of our own universe.
Yeah, because when you look up at the night sky, you aren't just looking at a static canvas of white dots, you're looking at a sprawling physics engine. I mean, every pinpoint of light is broadcasting a very specific color-coded message across the vacuum of space.
A message about its temperature and history, right?
Yes, temperature, its violent history, and honestly, its inevitable death.
And I mean, those color-coded messages are suddenly right at the center of pop culture right now. The catalyst for this is obviously the massive 2026 James Gunn movie, Supergirl.
Oh, absolutely.
With Millie Alcock playing Kara Zor-El, traveling across the galaxy, and audiences are finally seeing firsthand how radically different colored suns rewrite Kryptonian biology.
Right, which has everyone asking how this mechanic actually works under the hood. So that's the core mission for this deep dive. We're going to break down the real-world physics behind why stars are different colors in the first place.
Right.
And from there, we'll bridge that hard science over to the comic book biology of how those specific stellar wavelengths unlock or completely destroy the godlike powers of characters like Superman and Supergirl.
Okay, so before we can understand how a yellow sun gives an alien heat vision, we need to understand what star colors actually mean in our own reality. Like, what is dictating the color palette of the universe here?
Well, it really comes down to a fundamental concept called black body radiation. Basically, any object in the universe that has a temperature emits light. And the hotter the object, the higher the energy it pumps out. High energy light travels in these really tightly packed short wavelengths. So because blue light has the shortest wavelength in the visible spectrum, the absolute hottest, most violently energetic stars actually burn blue.
Okay, let's unpack this because that completely flips my daily intuition. I mean, in my brain, red means hot and blue means cold, like the faucet handles in my bathroom.
Yeah, that's how we're wired on Earth. But in astrophysics, a blue star is the ultimate cosmic furnace. They are massive engines of crushing gravity.
Yeah.
And that immense mass forces their cores to undergo nuclear fusion at just a reckless pace. I mean, they are burning at tens of thousands of degrees.
So they burn through all their fuel super fast then.
Exactly. Because they chew through their fuel so aggressively, a blue star might only last a few million years. Which, on a cosmic timescale, is just a blink of an eye.
Live fast, die young, and leave a giant explosion.
You nailed it. They die in these magnificent supernovae. And in those violent deaths, they forge and scatter heavy elements like oxygen, iron, and carbon across the galaxy.
Wait, so the iron in my blood was made in a blue star?
Quite literally, yes. Forged in the death throes of a blue star. But as we move down the temperature scale, the wavelengths stretch out. We pass through the white stars, which represent this highly pressurized equilibrium.
Like a hidden intensity.
Yeah, intense heat, hidden beneath a deceptively calm, balanced exterior. And eventually, the light stretches further into the yellow spectrum.
Which brings us to the quiet heroes of the galaxy, right? Yellow stars. Or I think the sorts call them G-type stars.
Yeah, a G-type classification just means you're looking at a main sequence star burning hydrogen into helium at a moderate surface temperature, usually around 5,000 to 6,000 Kelvin.
And our sun is a G-type, right?
It is. They're medium-sized, and they burn their fuel at a very measured pace.
And that measured pace is the key to everything for us. I mean, you need that long, gentle consistency for a planetary climate to actually stabilize.
Absolutely.
You need billions of years of a steady thermostat for complex life to evolve. Otherwise, your planet just gets sterilized by the violent radiation of blue star.
Exactly. And then you reach the absolute bottom of the temperature scale where the light stretches out into the longest visible wavelengths, the red stars.
Right.
What's fascinating about the red end of the spectrum is that it contains two completely contradictory types of stars. On one hand, you have red dwarfs. These are incredibly cool, tiny stars burning fuel so slowly they could outlive the current age of the universe.
They're the ultimate cosmic survivors.
They really are. But then on the other hand, you have the red giants.
Oh, right, the massive dying ones.
Yes, they've exhausted their core fuel, which causes them to swell up to monstrous proportions. And as they expand, their outer layers cool down, shifting their light to red.
And they swell so much they eat their own planets.
Often, yes, they consume their inner planets entirely.
So if we look at these colors as human lifetimes, there's actually a really poetic emotional takeaway here. Like, blue is a blazing, violently energetic youth.
Right.
Yellow is a stable, productive adulthood. And the red giants are the swollen cosmic elders, nearing the very end of their run, preparing to return their elements to the dark.
It is a beautifully balanced real-world life cycle.
Okay, so if a yellow star is the perfect, calm incubator for fragile human life on Earth, it's wild that this exact same gentle radiation acts as a biological steroid for a Kryptonian.
It's a huge leap.
Right. Like, how does a fictional alien's biology physically react to moving from an ancient, cool red star to our hot, stable yellow one?
Well, to explain the physical mechanics of that transition, we look to a foundational piece of Superman lore from Elliot S. Magen's novella, Starwind's Howl.
Oh, right.
He introduced a scientific concept called the photonucleic effect.
Huh.
The underlying premise is that organic matter evolves differently based on the radiation signature of its native solar system.
And Krypton orbited a red giant named Rao.
Exactly. So Kryptonians evolved over millions of years to survive under the heavy gravity and low-energy red light of that dying star.
Oh, okay.
When a Kryptonian's body is suddenly introduced to the higher energy environment of a yellow G-type star, their biology experiences a massive shock. I mean, upon first exposure, their body actually goes into a momentary, almost imperceptible coma.
Like a microscopic pause while the body rewires itself?
Yes, in that fraction of a second, their cellular structure violently evolves. The nucleus of every single cell grows a temporary protective shell, a carapace,
Wow.
and the atomic bonds unbind slightly. Every electron in every atom of their body jumps outward by exactly 1 quantum level. The physical binding space between their molecules expands by a fraction of an angstrom.
Here's where it gets really interesting, but also where I'm struggling with the mechanics a bit. An angstrom is a measurement so incomprehensibly tiny we use it to measure atoms.
Right.
But if their atomic structure is literally expanding, like if all those electrons are moving outward, shouldn't a Kryptonian physically swell up like a giant balloon under a yellow sun? Why do they stay the same size?
It's a brilliant question. The lore actually addresses this by explaining that while the spatial arrangement of the atoms shifts, they don't gain additional mass.
Okay.
Instead of puffing out, the expanded molecular structure locks into a highly rigid, energy-absorbent lattice.
So it's like a sponge expanding with water, except the sponge is solid matter turning into steel. The physical space between the atoms changes, the structure realigns, and something ordinary becomes practically unbreakable.
That is the perfect way to visualize it.
Yep.
Their molecular lattice becomes exponentially denser and tougher, and more importantly, that expanded space between the atoms turns their entire body into a living photovoltaic cell.
So they just absorb and metabolize yellow solar radiation indefinitely?
Exactly.
Wait, let me push back on this comic lore for a second. If we go all the way back to the Golden Age, to 1938, when Action Comics #1 first hit the stands, did the original writers actually use this incredibly complex quantum-level sun explanation to justify his powers?
Oh, not at all. They didn't touch it.
I didn't think so.
Yeah. Early on, the explanation relied entirely on gravity and basic evolutionary biology. Krypton was framed as a massive planet with crushing gravity.
Right, so he was just super strong.
Because Kal-El species had evolved bone density and muscle mass to survive that environment, coming to Earth's relatively light gravity gave him an immense physical advantage.
Like an astronaut bouncing around on the moon, but weaponized.
Exactly. That purely gravitational explanation justified his basic early powers. His invulnerability was just dense skin that could stop a bursting artillery shell. His super speed was just him running at 30 miles per hour.
And he famously couldn't fly back then.
Right, he could just leap 1/8 of a mile over tall buildings purely because Earth's gravity couldn't hold him down.
So when did the sun stuff come in?
Well, gravity gave him the muscles, but as the comics evolved, writers needed a mechanism for the truly godlike, energy-based powers. That is where the yellow sun's photonucleic effect became essential.
To explain the crazy stuff.
Yeah, the solar energy battery concept is what powers heat vision and X-ray vision. It even explains actual sustained flight, which is theorized to be the Kryptonian magnetically polarizing their sun-charged body against the Earth's own electromagnetic field.
That is so cool. So let's apply this biology to the new 2026 Supergirl movie. The film draws heavily from Tom King and Bilquis Evely's comic series, Woman of Tomorrow, and it really leans into the duality of these stars.
It does, very heavily.
Because under a yellow sun, Kara-Zor-El is that living solar battery.
We've seen this incredible regenerative capability before, right? Like
Yeah.
David Corenswet's Superman rapidly healing inside the sun after taking a beating from Ultraman in his 2025 film.
Yes, but under a red sun, like Krypton's native star Rao, that entire photonucleate process shuts down. The radiation from a red star is simply too low energy to maintain that expanded atomic lattice. So they just lose it all.
They lose all their stored yellow sun energy. They're stripped of their powers and become, biologically speaking, entirely human.
And the Supergirl movie uses this red sun vulnerability in a brilliantly visceral way to explore her humanity. When Kara is under a red sun, her hypermetabolism stops working, meaning she can actually sit at a bar and get drunk.
Right, she can experience normal human things.
But it also means she can experience raw, severe physical pain.
And that physical vulnerability drives the entire plot. Under that red sun, her companion, Krypto the Superdog, is shot with a poisoned arrow by a mercenary named Krem of the Yellow Hills.
Right, and because Kara has no powers under that red sun, she can't just fly Krypto to a hospital. She is forced to use a clunky physical spaceship to travel across the galaxy to hunt Krem down. It grounds a godlike character with real stakes.
It really does. But the cinematic universe also introduces an even more terrifying color to the spectrum, the green sun.
Oh, right, the planet Barrington.
Yes. The artificial planet Barrington orbits a green sun. And this isn't just a star that depowers a Kryptonian like a red sun does. This is a stellar engine that has been entirely infused with actual kryptonite.
Which is terrifying. Its light isn't just low energy, it's lethally toxic. A Kryptonian standing under that sun is being actively irradiated by the destroyed radioactive remains of their own homeworld, pumped out on a massive stellar scale.
Exactly.
So what does this all mean for their sheer endurance? We know Superman is tough, but how do you handle being actively poisoned by an entire sun bearing down on you?
The contrast between how Clark and Kara handle this exact scenario is fascinating in the source material. Superman was once trapped on Barrington, and he considers that specific experience his absolute closest brush with death.
Wow, even compared to fighting Doomsday.
Yes, even compared to being beaten to death by Doomsday. And yet, Superman was only trapped under that green sun for 45 minutes before the Justice League managed to mount a rescue.
45 minutes was enough to almost kill the Man of Steel.
But Kara-Zor-El's experience on Barrington is fundamentally different. She was forced to endure the extreme, blinding pain of that toxic green sun for 10 agonizing hours.
10 hours.
10 hours, entirely alone, waiting for the planet's rotation to finally allow the green sun to set and yellow sun to rise so she could heal.
And while being actively poisoned to death, she couldn't just hide. She had to actively protect her young human companion, Ruthie, from predatory alien dinosaurs the entire time.
Exactly. And while the movie adaptation streamlines the threat slightly, they remove the dinosaurs, Kara still has to endure that horrific 10-hour wait while Ruthie is captured by brigands.
She out-endured Superman's absolute worst nightmare by a factor of 13. It really proves Kara's incredible resilience.
It really does.
Okay, so we've got yellow, red, and green suns firmly established on screen. But if you dig into the deep lore of the comics, the cosmic spectrum grants some utterly absurd wildcard abilities.
Oh, it's completely wild.
Yeah. Let's talk about the overdrives. Blue and white suns. If a yellow sun makes you a god, a blue sun apparently makes you a god among gods. It supercharges a Kryptonian to the point where they develop Superman vision.
Yes, this specific power manifested during the Escape from Bizarro World storyline. Superman finds himself on a rocky, cube-shaped planet called H-Tray, which happens to orbit a massive blue star.
Right, and the high-energy blue radiation charges him so much that he can shoot a red, blue, and yellow beam from his eyes that temporarily gives other people his powers.
It's absurd in the best way.
He uses this beam on his adoptive father, Pa Kent, empowering the old man to go toe-to-toe with a monster called Bizarro Doomsday on that planet.
And then you have the White Sun, which was featured prominently during the Warworld saga. Superman is trapped on an artificial planet, suffering from severe radiation poisoning and cellular decay under a synthesized red sun.
Okay.
But when his allies manage to hack the planet's engine and switch it to burn as a white sun, the sudden influx of perfectly balanced high-intensity light has a staggering effect.
It instantly cures his cellular decay, right? And he gains tactile telekinesis, meaning he can manipulate objects at an atomic level just by touching them.
Yes, he taps Lex Luthor's incredibly advanced armor and instantly disassembles it with a single thought.
Ooh, cool.
The white sun also grants him the ability to teleport across light years. During a massive battle to save his Philosian adopted children, Osel-Ra and Otho-Ra, from the villain Metallo, that white sun energy allows Superman to literally manifest a giant glowing energy construct of himself.
So blue and white suns basically turn him into a reality-breaking anime character. But here's where real-world physics throws a wrench into comic mythology, according to that Reddit breakdown in our sources. Green and purple stars don't actually exist in nature.
They don't. Going back to blackbody radiation, a star's color is determined by its temperature curve across the electromagnetic spectrum. The sequence strictly goes red, orange, yellow, white, and then blue.
Wait, so no green at all?
Well, our own sun actually peaks in the green part of the spectrum, but because it emits all visible colors simultaneously, our eyes perceive that mixture as white or yellow light, aided by atmospheric scattering. You cannot have a star that naturally appears purely green or purple to the human eye.
Well, try telling the DC universe that those colors violate the laws of thermodynamics, because not only do they have a green sun, they have orange and purple ones too.
Yes, they do.
Under an orange sun, a Kryptonian's power is cut exactly in half and they go completely blind. But the purple sun is my absolute favorite piece of trivia from this deep dive.
The purple sun grants a Kryptonian reality-altering, mind-over-matter powers.
He achieves literal omnipotent godhood under a purple sun. And how did the Man of Tomorrow use this ultimate cosmic power to reshape reality? He used it to manifest the exact amount of pocket change he needed for bus fare and a magazine in Metropolis.
That is peak comic book logic.
Right. You have the power to rewrite the universe, and you use it to avoid breaking a $20 bill.
But if we connect this to the bigger picture, it perfectly captures the unique joy of comic books. Writers take strict, awe-inspiring astronomical rules, like the billion-year life cycles of massive stellar engines, and they stretch them to their absolute most whimsical limits.
All to serve the story of an omnipotent alien immigrant who just wants to live a normal, decent life in a human city.
Precisely.
So the next time you step outside on a clear night and look up at the sky, don't just see uniform white dots. You are looking at lifetimes. You're looking at violent, blazing blue youths. You're looking at stable, warm yellow adults. And you're looking at swollen, ancient red giants collapsing under their own weight and giving their elements back to the dark.
It is a perfectly balanced physics engine that just so happens to fuel the greatest superhero mythology of our time. But this intersection of real physics and comic lore leaves us with one final, terrifying question to ponder from our sources.
Oh, I know where you're going with this.
Astrophysics tells us about white dwarfs, the incredibly dense, fading embers of dead stars. And in the comics, exposure to a white dwarf enhanced Superman's powers even further. It actually granted normal humans like Jimmy Olsen and the Wonder Twins Kryptonian level strength.
A dying ember turns normal humans into supermen.
Exactly. But science dictates that eventually, over trillions of years, a white dwarf will lose all its residual heat. It will eventually cool into what is known as a black dwarf.
Wow.
This is a stellar remnant so ancient, cold, and dead that our universe isn't even old enough for a single one to exist yet.
So if the fading light of a white dwarf can rewrite human biology, what wondrous or perhaps terrifying abilities would a Kryptonian unlock if they ever encountered the theoretical frozen darkness of black dwarf?
We will leave you to imagine the possibilities of that frozen darkness on your own.
Keep looking up at those colorful pinpricks of light. Until next time, thanks for taking this deep dive with us.